Well, good evening, everyone. Can you all hear me, or do I need to turn on the room mic? Is this working, those in the back? Yeah? Okay. Keep things simpler because we are live streaming, and having two mics might make things more complicated. So welcome, good evening. My name is Zachary Klein, and I'm a software engineer on the Grails team at OCI. And hopefully you're here to learn about using React with Grails 3. All the slides and sample code are on GitHub at that bit.ly URL. I have updated them somewhat, and I will push the updates later this evening. Let's see. About me, like I said, I'm at the on the OCI Grails team since 2015. I've been using React since about the same amount of time. I'm also the creator of the React profiles for Grails 3, as well as a Webpack profile, and I've written some documentation, some guides on using React with Grails. That's my family, my wife Beth, and our two boys. We live here in St. Louis. A couple things before I get started. Like I said, I've written some documentation. There's a couple of guides at this new website, or URL, guides.grails.org. And there's two of them there specifically about React. There's using the React profile, which will be a little bit of what we're going to talk about today, and then also a more general guide on building a React app using Grails. And these are really cool. These guides give you a starter application and a complete application and all the steps in between, all in one handy zip file. So those are pretty cool. Check them out. And then also we have a new feature on the Grails website, start.grails.org, where you can generate your own Grails application without actually installing Grails. Just download it and you're ready to go. And you can choose, among other things, you can choose the profile, and I'll talk about profiles a little bit if you're not familiar with those. You could choose a Grails profile, including React, and so you can download a Grails React application that way very easily. So something else to check out, bookmark. Okay, so I'm going to cover potentially a lot of stuff today. We'll see how far we get through, because some of these things are kind of optional. If we run out of time, I won't keep you here too long. I can drop some things off, but we're going to have a brief primer on React, kind of depending. I'm going to query of the room in a moment, how familiar we are with the library, kind of get a sense of where it fits in the front-end developer space, and then the bulk of the talk hopefully is going to be on how we actually use React with Grails, with the Grails framework. And there's several different ways of doing that, some plugins, some profiles, as I mentioned, and also maybe if we have time for dessert, we'll look at something called isomorphic React, server-side rendering, which can be something very interesting. So what is React? How many here in the room, I didn't do this, this was supposed to happen earlier. How many here in the room are familiar with React, have ever used it? Okay, some. How many here are familiar with Grails? Okay, how many are not familiar with either? React or Grails? Ha, yeah, right, Jack. Okay. Okay, so it's a pretty even split. So React is a JavaScript library from our friends at Facebook. And I do want to emphasize that it is a library. It is not a framework. React is often compared with or pitted against Angular, for instance, and it's not really a fair comparison. They're not trying to do the same thing. React is a library. It's focused entirely on rendering a view, and while it can be certainly part of a larger and more complicated application, it's not trying to do everything that Angular is trying to do. And so Angular versus React is not really apples and apples. Some describe React as being the V in MVC. So it's not providing, it doesn't give you services, there's no $sign HTTP to make REST calls. Those kind of features you're going to have to either handle yourself, handle with a backend framework, or some other library. It's a fairly minimal API. It's not a very complicated framework. And a lot of the times, a lot of the stuff that a lot of frameworks give you little magic wands to do things with, you're going to do that kind of stuff in plain JavaScript, which is not as bad as it sounds. Hopefully, I'll prove that to you. Oh, I'm sorry. I'm letting you miss out on one of the. There it is. So I'm not going to read the list to you. There's a few key features. Again, we're going to do a quick primer of React. We're not going to. This is not a React class. If you're looking for that, talk to Mark. But we will go a little bit over some basics so that the demos all make sense. You should be able to follow along with that. There's a few key features. The virtual DOM. Actually, I should back up a little bit. One of the things I find it's important to understand about React is that it is not exclusive to the browser. And so you're not going to be, it's not a sort of framework or library like, say, jQuery, where you're attaching things to selectors. It's actually fairly isolated from the browser DOM. And the code you create in React can be rendered to a browser, but it can be rendered to other things as well. It can be rendered on the server. It can be rendered into memory for testing purposes. It can even be rendered onto native mobile platforms like iOS or Android. So here's a super simple, about the minimalist bit of React you can get to render something into a browser. You'll note that we are importing two libraries, React and React DOM. Again, React itself is independent from the DOM, and so if you want to write to the DOM, if you want to write out to a web page, you're going to need to use the React DOM library. This is a really trivial example. We're just rendering out a hello world h1 tag, and we're calling where React DOM, it takes a element to attach our output. In this case, we're getting an element by ID of root. So if you're not familiar with React, you're probably a little bit curious about this bit of what does not look like JavaScript right in the middle of our JavaScript component. And this is something that is very powerful and somewhat controversial feature of the React library, and we're going to be using it a lot, so I'm going to introduce it right away. And this is called JSX. Now, the important thing to know is that JSX is not HTML. So even though this, don't believe your lying eyes, these are not truly H1 tags. This is all still JavaScript. Now, this is going to render H1 tags, and so you're correct in perceiving it that way, but this is a JavaScript component. This is all JavaScript, and we'll see how that works in just a moment. JSX has been described as a syntax extension of JavaScript. It's basically some syntactic sugar, if you will, and behind the scenes, it's going to be turned into function calls, and we're going to see what they look like in a minute. JSX is optional. You don't need to use JSX to use React, and there are those who prefer not to use it. I find it to be a very powerful way of describing components, and I'll hopefully show why in a moment. Let's look at a little more interesting example, though. Okay, so now instead of just writing an H1 tag onto the document, we're going to actually define a component. So we're using a more advanced feature of JavaScript. This is coming in ECMAScript or ES6. It's a JavaScript standards body, and I'll talk a little bit more about that in a moment. But the point is, we are defining a component called greeting, and it has a single method, a render method. Every React component has a render method. It's going to render something out to the view, and inside our render method here returns effectively the same H1 tag. Only difference is now is that instead of just rendering a static string, we are accepting an argument to our component through our props. Every React component has a set of props, which are effectively attributes when you see them in JSX. And so as you can see in our render call now we're rendering our custom greeting component instead of our H1 tag. And our prop is this little name attribute right here. We pass in that string, and that's going to be in the output of our H1 tag. So try not to get too bothered by things like class and import. We're going to talk about that in just a minute. But that is a basic React component, about as simple as it gets. This is the same component. This time I took out the newer JavaScript. This is all using older ES5 kind of conventions, right? So instead of having a class, we're calling React.createClass and assigning it to a var. So this is more typical JavaScript that we're used to. And I just want to show it to you so you get some sense, hopefully, of where this is coming from. In practice, I write most of my React code or all of my React code in ES6, and I'll explain why in a moment. But hopefully that kind of anchors you into what's going on here. Our React class can be created by calling React.createClass, or we can define it as a JavaScript class in ES6. Okay, so a little more about JSX. Is anyone else bothered by JSX? Does that look kind of weird to you to have JavaScript and then angle brackets in the middle of it? That bothered me for quite a while. When I was learning React, I was trying to figure out how to get that out of my React code. And I discovered that I was thinking about things the wrong way. But I want to show you exactly what these angle bracket things that are not HTML, what they turn into. So watch closely the the two pieces of JSX we have here, right? We have in our render method, we have this h1 tag, and then of course we have our custom component used on here. Now watch those carefully. So we've replaced those JSX tags with what React is actually doing under the covers. Those tags are effectively aliases to calls to react.createElement, and that's really all they are. The curly braces that you see in the middle, let's see here, we had the curly braces around our this.props.name. When React is parsing the JSX, it needs a way of knowing, okay, I'm done with tags, I'm going back to regular JavaScript. And that's what those angle bracket, or curly braces, I'm sorry, are telling us. And so within here, we can have any plain JavaScript you want. If you're familiar with Grails and you're familiar with Groovy strings and a GSP page, it works very similarly to that. So I'm going to hopefully make this a little more clear to you. So now I've labeled the arguments to react.createElement. You'll see there's 3 arguments. There's a name, there's props, and there's body. And the props and the body are both optional. Okay, so when we're creating an element, we have to tell React what element we're creating. And by lowercase indicates that this is going to be the HTML tag. If it's uppercase, we see in the second example, it's going to be our custom component. And again, optionally, we can pass in props, and optionally, we can pass in a body. And if we don't have one of those, we just pass in null. So our top here, we're at the top example, we're creating our h1 tag. It doesn't have any props. It just has a body, which is our string. And the second example, we're creating an instance of our custom component. It does have props, which is a plain JavaScript object, and it has no body. So now if you watch that again, as I go back to the old example, all the same information that we saw in those create element calls is expressed in JSX. So React gets all the exact information it needs from a much, generally speaking, a much more terse, concise syntax, and one that becomes much more concise and pleasant when you start getting slightly more complicated components. So here is hopefully you don't have to read the code exactly. Hopefully you can just tell it's more code than we had before. All I've done, this is our same greeting component. I've just added an unordered list and a couple of list elements with links. And just with that little bit of additional markup, I had to chain a bunch of create element calls. And this is the problem with expressing UIs through function calls in JavaScript, is that it begins to get pretty unwieldy and hard and difficult to read and to reason about. And so if I convert this plain JavaScript back to JSX, it's much more apparent what's going on, right? And so as those of us who are web developers, HTML and XML, it's almost as good as visualizing our code, right? I mean, that's pretty much the language of web presentation. And so to have this sort of syntax as a way of expressing and describing our view makes it much easier to reason about what we're doing. Now some, and including myself, still find this to be kind of icky. And one of the common complaints that you'll hear is this is violating a separation of concerns. And that was an argument that I would have made at one point. And others have had this discussion, of course, before me. I'm not breaking any ground here, but the answer from the React perspective is that this is not a separation of concerns issue, because remember, React is only a view library. Andrew Ray had the link to his article. They had a really good post on this. React is only the view layer, so we are only in one concern. So the rationale for bringing this HTML-like syntax into our JavaScript code is basically acknowledgement that one way or another, we're going to end up having to complicate one side or the other. If we're going to split things up and have separate markup and separate logic, then we're going to have some sort of additional magic to link up the two, right? We're going to have, and different frameworks have different ways of going about this. React is just saying JavaScript is by far the more powerful language. Let's just write everything in JavaScript, and let's have a easy and fairly XML consistent way of expressing those parts of the application that are expressing the view output of the application. Let's see. Again, this is optional. You can write, as I said, you can write the create element calls yourself. But in practice, I found that JSX makes it much easier to reason about, especially a more complicated application. And it's the pain on your eyes does go away. It becomes actually quite pleasant in my experience. Now, even though we say we're only in one concern, this is all about the view, in practice, it does become a good idea to separate your components into what might call presentational versus container components. So you end up having top-level components, let's say your app component, your mother component that renders the entire application, that has a lot more logic, that might know how to make REST calls and to do more work. And then you have lower-level presentational components, like our greeting component, that just takes some data in its props and renders it out. And that's where really where React shines, is in giving you a clean way of expressing how you want your content to look. There's an article on the Facebook documentation. I don't have the link here, but it is on the repo, called Thinking in React, which is a great resource for learning how to structure different kinds of components. And we'll see a little bit more examples of this as we go along. Okay, component state. I'm going to try to wrap this up quickly here with our primer. So I mentioned that React elements have props, right? They have attributes, arguments you can pass in either in JSX or through your create element call. They also have or can have state. And state is simply a variable that's directly on the object. We have this.state. It's a JavaScript object. In this case, we've added a state variable called greetings. We have an array of strings, different greetings, and then don't worry too much about the specific code here. All we're doing is in our render function, we're randomly picking one of our greetings and rendering it out in our h1 tag. And we could have populated this list from a REST call. We hard-coded it in this case, but we could have made an AJAX call, gotten a list of strings, and loaded it. We could have gotten it from user input. The point is that state gives you a place to store data that's internal to your component. There's no way you don't access state inside of a child component. Each component has a handle on its own state, and if you need to share state across your application, you're going to do that primarily using props, right? You're going to take a state variable and pass it in as a prop to a child component, and that's how you can pass your data through the application. And that's important because state is how React actually works. So the way React renders your app is it takes the current state, it renders out a view, and then when state changes, React does it all over again. React will re-render your entire app because not the entire app, but it'll re-render everything downstream based on that change in state. And that sounds rather inefficient because you could end up re-rendering the UI potentially every time the user types a key in a text field, for instance. If you have that text field that's going to some value in your state, every time it changes, React is going to re-render your entire application, which sounds inefficient, but it's not because of the virtual DOM, which is React's sort of secret sauce. So instead of immediately re-rendering your entire view, what React actually does is it renders into memory as what they call a virtual DOM, an in-memory representation of the DOM. It renders into that and figures out what the minimal number of changes that are needed to make your current view look like, to reflect the new state. And so it only actually has to render our star, the only thing that changed, right? The rest of the output stayed the same. It only had to make that minimal change that was required by the change in the state. And so that is how the React component lifecycle works. There's other features we're not talking about right now. There's lifecycle methods, little hooks you can get into when state changes or when props change to do custom logic. But that's basically the cycle of a React component. It renders out based on your control logic. It's going to render out your component, and then when the state changes, it's going to figure out what it needs to re-render in order to reflect that change. Any questions about that so far? Does that kind of make sense? Confusing? Okay, I see some nodding. That's a good sign. Okay. One last point I want to make in this primer, and let's see, we're going. Wow. Okay, that's not too bad. Not too bad. Okay. We started at 6:30, right? Okay. Component state. So where should state go? That's a big problem in a lot of React applications. In my experience, the difference between bad React code and good React code is state management. Where do you put the state, right? Every React component potentially can have state, but state also ends up being the cause of a lot of your woes, a lot of bugs. And it can become a hot potato situation. Where do you want to keep that state? And this is a big topic. There's a lot of different options. Like I said, each component can have its own state. You can store state in a top-level component and just pass down the portions of it that are necessary to your children components through props. And then you can also externalize your state entirely and use a library such as Redux. And that will take the state completely out of your application into what we call store. And then there's API to allow your components to connect to that store and pull out just the parts of state that they need. And my recommendation, and for most React apps that I work on, this is my default, is that second option, to keep the state centralized in a top-level component if possible, and only pass down the portions of the state that each child component needs through their props. And the reason why I like this approach is that it makes it fairly straightforward if you find you need to move to Redux or Flux or another one of these external store libraries, because your state's only one place in theory needs to be affected. What I don't recommend is starting off with necessarily. I don't personally recommend starting off with Redux or Flux right from the get-go, especially if you're just learning React. I found a lot of tutorials they throw in React and Redux and React Router and a bunch of stuff all together. And I think that can inhibit the learning process and sometimes make your apps more complicated than they might need to be. So that's just my recommendation. None of this is specific to what we're going to talk about as far as Grails goes. This is just how you structure and build your React application. Again, state's necessary for any useful application, but just be careful with it and don't spread it. Really try not to spread it around. Is my main caution. It's not a good experience. Okay, so that kind of brings us to the end of our React primer. There's a bunch of other features, lots of features I haven't talked about. Lifecycle methods. Again, React exposes different portions of the rendering cycle to you, so you can say, oh, I just got new props to my component, but maybe I don't need to actually, with this change of props, do I necessarily need to update this component? Maybe I can skip this entire rendering process because I know, hey, with this condition, nothing's changed. I don't need to update. There's different ways of you can hook into right when a component is like, say, mounted, right when it's placed onto the page. Maybe you want to make an AJAX call or something like that. So there's lifecycle methods, event handling, state management. We talked about a little bit. Prop types, really powerful feature. You can define all of our components have props. You can actually specify certain props as being required. You can specify what type they should be. Maybe name, our greeting component requires name, and it must be a string. It can't be an object, for instance. And so if you use prop types, then React will kind of give you meaningful error messages and give you some help. If it'll tell you, hey, this component, it was expecting an object, but it got an array. Well, that's something that could cause some pretty hairy bugs down the road. And so React prop types will help you out there. DOM access using what we call refs. Like I said, React is insulated from the DOM. You're not supposed to reach out and play with the actual web page, but there is a way out if you have to. There is a way to actually get a hold of specific elements. React can be used for a single page application. It can be used for just a portion of application. You can have a subcomponent on a traditional web page that's rendered by React. And this is a quote from the Facebook team, the React team. In their opinion, this is the premier way to build big, fast web apps with JavaScript. And it has scaled very well for us at Facebook and Instagram. And those folks, they deal with things like scaling. Okay. So like I said, React is just a view library. It's small, it's focused by design, but it's often used with a lot of other things. And I mentioned Flux and Redux already. Those are both state management libraries that are commonly used. There's React Bootstrap as our wrapper around the Twitter Bootstrap UI framework, which we'll see a little bit of that in one of the demos. React Router. So if you're not familiar with single page applications, one challenge is that it's a single page. And you might have many virtual, not virtual, you might have many pages or panes or whatever you want to call them in your application. And often you find it'd be nice to be able to give URL-based routes to these portions of your application. Let's say you have a settings, a settings page in your single page application. You want to be able to have a link there. You want to be able to use browser history and go backwards and forwards through your single page application. Routing is the way to do that, and React Router is not the only option, but a very popular library for that purpose. Immutable, I'm not going to talk about it really, but it provides immutable data structures and some really nice API for handling collections and things of that nature. And you'll often see it used in React applications, so just be aware of that. And then Fetch and Axios are a couple of libraries for performing HTTP requests. Like I said, there is no $ HTTP or anything like that, like you would have in Angular to make REST calls. And so you'll have to use some means of doing that. And I personally prefer Fetch, but they're both good options. I'm using Fetch in these demos. Fetch, in theory, is going to become part of the standard JavaScript API for making network requests. And so that's why I like it. Oh, Mark.
One thing I would add on this slide is that a lot of people criticize React, saying that because it's just a view layer, you're left with all of these choices to make.
Mm-hmm.
And my answer to that is your choices are on the screen here. It's not a lot of choices.
Yeah, that's been very nice, especially recently, is that there really has been a consensus around a fairly small number of libraries. I mean, this list here would get you a long ways. And that's a great point. There's actually an article here from TopTal, Navigating the React Ecosystem, and they basically coalesce on almost this exact same list as far as, I think they prefer Axios over Fetch, but it doesn't have to be as confusing as it might sound. There really are a lot of there really has been a lot of consensus around a lot of these libraries. Okay, so next part of our React primer is going to be kind of a look at what React, sort of the landscape. React is not usually used by itself. It can be. You literally can put 2 script tags in your HTML head in your document and use React that way. But usually you're going to find it used with a bunch of friends. And of course, one obvious one is Node.js. We're all here. We all know what Node.js is, right? It's something we are all at least aware of, right? JavaScript runtime, because somebody got the idea that it'd be a great idea that we should run JavaScript on servers. It interprets JavaScript using the Google V8 JavaScript engine from Chrome. NPM is a package manager for Node, and NPM is quite often the preferred way of installing React for a lot of people. It's not required, and we're going to see ways we can do this without it, but you will see it and hear it quite often. See, Webpack, we're going to talk quite a bit about Webpack. Webpack is a module bundler. That's the official title. Seems like an understatement to me, but it's going to be an important tool we're going to talk about more later. Babel is a transpiler. And so remember I mentioned that, I think I mentioned this, that these funny angle bracket JSX things are turned into function calls. And that's the React code. I guess I should sorry about this. I should back up a little bit. React code, as it's written, as you see in the demos we're going to look at, it won't work in a browser for the most part. Babel is a tool that will take JavaScript that's written to newer standards using things like ES6 or using JSX and translate it into plain old JavaScript that browsers actually know what to do with. And so Babel becomes an important player in this tool chain. We'll talk more about that in a moment. ES6 again. Oops, sorry. Oh, I have to click through all these things again. ES6, the next version of JavaScript. Okay, let's move on. Let's see, Node, NPM. I'm sorry, I think I haven't given this talk since the G3 Summit, and I apparently forgot that I had slides for each of these guys. ES6, talk a bit about that. So all of the demo code that I'm going to show you is using ES6. And the reason why is because in most cases, if you're set up to run React, it's not that much harder to also run ES6. Like I said, neither of them are going to work just as is in the browser. You've got to run them through some sort of a processor for them to work properly, unless you want to write them the old-fashioned JavaScript way, which I do not recommend. Babel, like I said, is a transpiler that will do that conversion for us. And Webpack is sort of the superhero of the story. Webpack is what's going to take our React code or our ES6 code and it's going to run them through whatever sort of processors they need in order to be consumed by the browser. And so Webpack, I found, is almost ubiquitous among React projects. We don't have to use it, and we're going to see how we can do without it. But it's very popular. It doesn't just handle React and JavaScript. It handles all sorts of file types. You can run almost any sort of static asset through Webpack, and it's a very powerful tool. And we'll see how it's used in a moment. Oh, one thing I was going to say. How many here are familiar with the asset pipeline, or just asset pipeline as a concept? It came from Rails. Grails has an asset pipeline that is very conceptually similar. Okay, if you know what the asset pipeline does, Webpack kind of wants to steal its job, is the way I describe it. Webpack is pretty much trying to do the same things that the asset pipeline was doing, although in a quite different way, and with a very different ecosystem around it. So why use React with Grails? Well, this is the Grails user group meeting, so that's partially why. But Grails is so how many here are not familiar with Grails? I saw a few hands. Okay, so Grails is a Java web framework. It's based on Spring Boot. It brings a lot of very powerful features for developing web applications, conventional configuration. It has excellent REST support. We're going to look at some features of that. We can generate RESTful URL mappings. We can customize the output of our API through JSON views. So we can actually, just like we have a view with HTML, for instance, we can describe our view as JSON and say, here's how we want our JSON to look, how we want to format it. We have support for things like WebSockets through the Spring WebSockets library. It uses the Gradle build tool, which gives us a lot of cool features like multi-project builds. The top there, I have GORM, the Grails object relational mapper. It gives you a really slick API for almost every data source imaginable. The problem is that, at least I found when I was learning React, is that it's not very clear how you use it with Grails. Now, part of that's because in a lot of cases, our React apps are running standalone as a front end and only communicating with some backend over a REST API. And in that case, it's that can be fairly straightforward. But if we want to use it together with a Grails application, that's not as apparent how you would go about that. Most documentation tutorials, they really do assume that I found that they tend to assume a Node or NPM based development environment. The project structure, it doesn't really, if you're a Grails developer, it's not obvious where where does a package.json file go? Where do these things belong in a Grails application? And then there's just and this is not specific to Grails. This tension between backend frameworks and the newer JavaScript, frameworks. I found a lot of really interesting information from Rails conferences and presentations at places from that community, because they largely have similar problems. It's not immediately apparent how to use these different kinds of frameworks together. And a colleague of mine at OCI, James Klee, did a survey, which was very interesting. He was working on an Angular profile. Oh, I forgot to mention that another feature of Grails 3 is profiles, where you can create a Grails application that is customized for a particular use case that only includes certain plugins or certain dependencies or certain default configuration that's aimed at, say, an Angular app or a React app or a REST API or a plugin. So that's so James was working on the Angular profile, and he was trying to get some feedback from the community. And what was interesting to me is that a large, and this is primarily Grails respondents, because that was who was being asked. For the most part, this was mostly published in Grails communities. And even among Grails folks, there were a lot of people who were leaning away from the asset pipeline, which has been the Grails way of handling front-end assets for quite a while. And so a lot of folks were interested in Webpack. In the second, so the first question here is, which build system would you like to see? Do you want to use the asset pipeline or Webpack or System.js? The other question is, where should the client code, where should your React or Angular code live? Where should it go? Again, there's a sizable number of folks that think it belongs in the assets directory, which is the asset pipeline convention. Others suggested source main web app, and others said separate app altogether. And there's pros and cons to all these choices. In the rest of the presentation, I'm going to try to basically briefly introduce how you go about each method. We're going to look at using the asset pipeline. We're going to look at using Webpack. We're going to look at a separate client and server apps altogether. So without further ado, React and the asset pipeline. So like I said, this has been the way that we've handled JavaScript and CSS and Sass and everything else in Grails since Grails 2.4 has been done through the asset pipeline. It's a very powerful plugin. There are plugins now for it that support React and JSX. It's a fairly recent development, so that's great. There's some really cool other Grails plugins that can work with the asset pipeline. And one of them we're going to talk about is the client dependencies plugin, where I talked about NPM is kind of the universal tool among Node developers for installing JavaScript libraries and frameworks and such. Client dependencies is a plugin that can do that for us without needing to even worry about NPM. And that can be appealing to a lot of Grails developers. And in general, this is a very Grails way of handling this whole front-end space. And so that's why I do want to talk about it. Now, there is a Babel asset pipeline plugin. And we talked about Babel earlier. Babel is a transpiler, can convert our ES6 or our JSX into plain old JavaScript, which we also can be called ES5. Unfortunately, this plugin I don't think is really ready for prime time. It's an interesting idea. I'm following it. I've had some communication with the author, but it's tricky. It's trying to run Babel and Webpack as a separate process in the asset pipeline machinery, and there's some issues there. So the one I do recommend is the JSX asset pipeline plugin. And this natively parses React and JSX. There's no Babel here at all. Dave Estes, the author of the asset pipeline, wrote his own lexer, his own parser. Really impressive to convert JSX into plain old JavaScript. So it follows all the asset pipeline conventions. If you're familiar with the asset pipeline, it keys off of file extensions. So JSX files are .jsx, and it'll pick them up, run them through the JSX plugin, and turn out the browser-ready JavaScript. Documentation is lacking on this plugin. It doesn't exist. Yes?
So if you go that route, does that mean you can't use ES6 in your JavaScript?
No, you can. And I'm going to show my demo. You can't, because there also is an ES6 plugin for asset pipeline, for the Grails asset pipeline. So you can use ES6 and JSX, but remember how it uses file name extensions? You have to pile them on top of each other. It's .es6.jsx, which I find a little bit ugly, but it does the job.
So the advantages to using those pair of plugins versus just using Babel?
The advantage would be for a team that is really invested in the asset pipeline. This is what they know, what they're comfortable with. So it really is an alternative to using Babel and Webpack. So I'm not saying this is the way to go. I'm just saying this is an option. If bringing in NPM does not sound appealing to you or your team, or you don't have developers with Node experience, you can now use React and ES6 in a Grails application without those tools. So we have a quick demo. Hopefully we can switch out of this presentation and back without messing up the live stream for folks. So I'm going to mirror my displays. all this code is on GitHub, so you can always take a look at it there as well. Oh boy. I hope we don't have to work on that resolution. Is that legible to everyone? Does that work? Okay. So I've got all my demos in one IntelliJ project here. I'm going to show the JSX asset pipeline one first. I believe I already have it running. Let's go ahead and browse to that. So I'm going to first show off the application. This is a very basic comment application. So I've got a couple of comments here. I'm going to put in a new one here. Decline. Hello, STL, Grails. There. And if I refresh the page, the comment I just posted is still there. So it was persisted to the database, and it's there. I can. This is about the extent of the React application here, as I can just post new comments. It is using a bit of, I believe it's using a bit of React Bootstrap, but it's pretty trivial. But that's all right. You'll notice that this is a case where React is only rendering this comment box itself. So, whoops, this thing is a weird mouse navigator. Okay, it's only rendering this middle section here. The rest of the page is a plain Grails view, and so that's an option. You can have your React components living in a regular page. They don't need to. Not every React app has to be a single page application. Let's go take a look at the code real quick for this app. So, like I said, this is using the asset pipeline, and so the JSX code is going to be found, the React code is going to be found under Grails app, assets, JavaScripts. And you see our file extensions. Is that legible? Oh boy. Is that legible to everyone? Is that too small? Okay. Yeah, kind of borderline. See if it gives me any. I'm going to try 720 and see what that gives us. How's that? That good? Okay. So you see the file extension types are .jsx, .es6, and that's necessary because I want to run this through both the JSX plugin to process our React code and the ES6 plugin to process my ES6. And we're using both here. So I'll take a look at the application. The asset pipeline has this concept of a manifest file, which is a file that includes other JavaScript files. If you're familiar with the asset pipeline, you know that. So we have a top-level application file, and it's going to import. So this stuff here at the top is just some defaults. We're not using this. But let's comment that out for now so you can hopefully ignore it. Oops. IDE error occurred. Of course you did. So we're importing React DOM, requiring fetch because I didn't use an import for that for some reason. Importing our comment box, and that's our top level component. If I go ahead and open up that file. So here is our, and this code is actually taken from the a React tutorial. So I didn't write most of this, but this is a more complex component than the other ones we saw. We can see it's a class, ES6 class, extends React component. We have some more lifecycle methods like component did mount. We have a custom function here that makes the AJAX call using fetch. It calls our API, it returns a list of comments, parses them, and saves them to the state. And I think I'm going to mostly breeze over this code because I didn't write it, and so I'm not quite as happy with it, to be honest. But I'll walk through our next demo, and we'll see a little bit more of how the event handling works. I want to show that off. The main thing I want to show off here is just the asset pipeline portion of this. So let me go to our build.gradle file, which is our project file for the Grails application. Let's see, the JSX asset pipeline plugin is right here. So we've included that as a Grail dependency. And in addition to that, we've also included the client dependencies plugin, which I mentioned. That is, let's see, where is that here? Client dependencies. There it is. Up here in our build script dependencies, we've included the client dependencies plugin. I want to show that off real fast. Remember, I said this is kind of the option for people who don't want to use NPM, don't want to use Node. And so if that's the way you want to go, I'm not recommending that necessarily, but if that's the way you want to go, here is an example of the client dependencies DSL. So client dependencies gives, actually, it's only this section, sorry, I selected too much there. Client dependencies gives you access to the entire NPM repository without installing NPM. And it gives you this really nice, that's still too small, I'm sorry. Anyone know the keyboard shortcut for zooming in IntelliJ? Command, what was that? There's always that option. Okay. It gives a nice DSL for it's not just NPM, it supports Yarn, which is a new dependency manager, and it supports some others, Bower as well. So it lets you specify the version and the name of the packages you want, and it downloads them from NPM, just like it would if you were using NPM directly. It saves them to a local cache. Actually, it saves them right here to this vendor directory. This is a really cool plugin, and if you want to take advantage of stuff in the NPM repository but don't want to use NPM, this is a good option, and a lot of folks have been using this to good effect, especially with folks doing Angular with Grails. So if you want to do React sort of the most Grails way possible, this is it. Client dependencies plugin to pull in. We're pulling in React here. We're pulling in React Bootstrap. We're pulling in the Fetch library. All through this client dependencies plugin, and then it's running the code through the asset pipeline, the JSX plugin. Does that all make sense? I'm sorry I breezed over the code there, but the upcoming samples I think are a little easier to follow. So I'll try to look more at the code on those next ones. Does that all make sense? Okay, so this is the only non-NPM Webpack Babel-based approach that I know of and that I'm going to talk about. So without further ado, we'll jump back into our presentation. Oh, I forgot. Got to turn mirroring back off. Okay, good. Live stream still look good, Cody? Is it right display? Great. Okay, that was our demo. So the asset pipeline is, again, just my experience, it's admittedly limited, talking with front-end developers. The asset pipeline is just not really in favor anymore. Again, it came from Rails. It's been used in Grails for a while. There's just not, that I've found, a lot of documentation or a lot of community activity around using the asset pipeline with these newer JavaScript frameworks and libraries. And so that's been a disadvantage I found. It's a lot harder to find help. It's much easier if you're taking the Babel Webpack approach, because that's what most folks are doing with these frameworks. And then because of that, the asset pipeline support for these libraries tends to lag. We only recently got, well, recently as in late last year, got JSX and ES6 support for the asset pipeline. And it works great, and I'm glad we have it, but you know, that's the kind of thing you're likely to face. That new tools will come out, and they come up pretty often these days in the front end space, and the asset pipeline is not going to be first in line. And it's very Grail-centric, which is both a good thing and a bad thing, depending on the makeup of your team. If you have a separate front-end team that specializes in Node or that sort of development environment, the asset pipeline is likely not going to be very popular there. But if you are a Grails team and you want to use React or Angular or these other front-end frameworks, and the Grails and the asset pipeline are what you're accustomed to and what you want to use, then this is a great option. And so that's, and you know, there are, if I've had some communication with Dave Estes, the author of the asset pipeline, and he will argue that the asset pipeline simply as far as performance and other factors is, he would argue it's a better approach than Webpack, but I'll let others have that debate. So Webpack, so it's a module bundler, typically installed with NPM. And it supports not just JavaScript, but it supports CSS, SAS, LESS, all the other, yes, thank you. All the other CSS supersets, I guess you might call them, that are out there these days. I'm not going to read the list to you, but it's got a lot of features. And one concept that you see a lot in Webpack is that it wants to take a bunch of dependencies, a bunch of modules. And this particular diagram doesn't really give you this, this very clearly, but the way Webpack works is it starts with an entry point, an initial file, usually the first file in your app, your main component perhaps, and it creates a web of dependencies. It figures out, okay, this imports that, this requires this. It pulls all together and then outputs bundles based on the asset types you have. So it can output. Often you'll just put out a single bundle of JavaScript. Your entire application will be compiled into one file, which you can then load in the browser to load your page. So here we got a bunch of ES6. So we got some stuff from, we got React, we got some stuff from NPM. Run it all through Webpack, and we get a plain bundle.js, which can be loaded on the browser and is all ready to go. I'm going to run through this here. It's just kind of giving an idea of, oops, this is kind of giving a quick idea of the conversion that happens through Babel. So Babel is used by Webpack as a loader, which, so I understand it is basically a processor. The asset pipeline has plugins. The Webpack has loaders. You specify, for instance, the Babel loader. There's loaders for all sorts of things, for files, for CSS. There's a loader for Java properties files, which is pretty cool. You can load I18N translation files through that into your JavaScript. And it converts it into plain old JavaScript for the browser. Gonna skip all this real fast. It's a little bit on the competition between Asset Pipeline and Webpack. A little over dramatic there, but there is a way of using them together, and that's what we're gonna look at here. So I'm gonna try to run through these next slides really quickly here and the demo. So the idea of using Webpack and Grails, you kind of have to, in order to do this, you have to sort of embrace the fact that Webpack wants to do this whole job by itself. And so what works best, I've found, is to give Webpack and NPM the job of taking care of the entire React application and basically having a self-contained React app within your Grails app. And then take the output of the Webpack tool, which is that bundle, and pass the bundle into the asset pipeline, and then allow the asset pipeline to do the rest of the work from there. This is what I found to be I've used this in several projects, and this is the least tension for using Grails and React in the same project, structure, if that's what you want to do. And the nice thing about this approach is that because the React app is self-contained, there's a fairly minimal amount of change that's to happen to move the React app out of the Grails application down the road. So if you're starting out with, say, a monolithic application and you want to have a React UI, but you're not ready to split it out just yet, it really just comes down to changing your Webpack config and moving the files into their own repository, for instance. And again, this is assuming that your communication between Grails and React is all happening over REST API, which is pretty typical. And the nice thing about this approach is that front-end developers can be using their tooling for the Webpack app, Grails developers using Grails on the Grails portion, and there's very little tension there in my experience. And we have a profile that does just this. And so there's the command for using the React profile. This is the initial version of the profile. There's a second version that we'll talk about in just a minute here. And this is basically what it gives you. So when you create a Grails app with the React profile, this is what you get. You get a Grails app with a self-contained React app. It's stored under source main web app. By default, you can move it, but that's where it's stored. It has Webpack already configured to bundle the application and output it into the asset pipeline. I'm not going to go through, that's just the directory structure. You can see this is, if you're familiar with Grails, this is basically a typical Grails application, a subset of it anyways. We have a package.json file for NPM. We have a Webpack config file for Webpack. And then our React code is stored here under source main web app. And then we can have whatever directory structure we want underneath that. And then Webpack outputs whatever code we're using in our React application. It turns out this bundle, and it drops the bundle into the asset pipeline. So we are just about out of time. So what I'm going to do is I'm going to jump back to the slides and go to the second example, and then we'll look at the code and try to wrap this all up. Okay, so that's the React. That's the first React, the React 1 profile, if you will. There's two versions of the profile. This is designed for a single project, a single application where you want your React code and your Grails code, your Grails application in the same structure. You want to deploy it in a WAR file all together. We use the Gradle node plugin. Again, Grails 3 is based on Gradle. Gradle has there's a node plugin for Gradle. It is very powerful. It allows us to do things like we could create custom tasks to run our JavaScript tests, for instance. I've done this for a project where we actually had in our Jenkins deployment pipeline, we could run our Grails integration tests, our Grails unit tests, and our JavaScript tests, turn out JUnit results, a JUnit XML, and have all of our test results all in one unified unified output. So that was pretty cool. Let's see. Oh, yeah, that's the thing I was going to point out is that because we're using Gradle, we can use Gradle to run the Grails application. So that means if you're a node developer, you can check out the project and run .gradle w boot run, and you're running your Grails application without installing anything. And same for the Grails developer, they can run Gradle Webpack, run the React application, or run the Webpack bundler without having to install npm. So the node plugin is part of what makes that happen. It wraps all that complexity. Okay, the final thing we're going to cover tonight is the separating the client and the server entirely, having a separate React application for the front end, separate Grails application for the back end. Very common pattern. Grails has a lot of great features to support this. It does require a standalone React app, which can add some complexity, and you have to configure cross-origin and things like that. It would look something like this. We have our Grails application, our React application, and communicating all over a REST API. The folks that the Facebook team has recently come out with a tool called Create React App, which makes it super easy to get started with a complete standalone React application. It provides a nice CLI for running and testing and building your application, and so it makes a really good choice for getting a start with our first React app. And so putting all together, we have this is the premier React profile for Grails. If you just say Grails create app and pass in the React profile, this is what you get. And so what this gives you is a Gradle multi-project build with a client project and a server project. Server project is our Grails app. It's using the REST API profile. And the client is a React app created by the Create React App CLI with some customizations. So when you use that, this is what the structure looks like. It's a separate directory. Again, it's all in a single Gradle multi-project build, which gives you some cool tools for running the server and the client at the same time if you want to do that. And also, like I said, you can share a Jenkins pipeline if that's what you want to do. We got our client app and our server app. Keep moving along here. And we're going to demo this real quickly. So I'm going to show off both of these options here. So I have two projects here, React with Grails and React with Grails multi-project. This first one here is using the first approach, okay? We have source main web app. Was that? Oh, I'm so sorry. I forgot to turn on mirroring. Just a minute. I have to turn on 720p. Okay, we're just about done here. Okay. You all see the screen now? It's flickering. I'm not sure why it's doing that. Sorry about that. Okay, so this is our source main web app directory, and this is our React application. Our Webpack config, okay, I didn't talk about this in detail, so if you're not familiar with Webpack, this is probably scary. It's not as scary as it looks, but this is the key point here is that we are telling Webpack the entry points to building our bundles. In this case, we have two bundles, one for index and one for books. We tell it where to find that, and then we configure where the output should go. And in this case, we want it to be dumped into Grails app assets JavaScripts, which is the asset pipeline. Remember, this approach is where we're letting Webpack bundle the application, dumping it into the asset pipeline. I already have this up and running. I'm going to go ahead and show you what it looks like. Okay, so we can go ahead and here's a list of a few of my favorite books. You can go ahead and add, let's see. If you're familiar with Groovy and Grails books, this is kind of a golden oldies list. So we just persisted a new book to the database. I can refresh the page. It's still there. I'm not going to walk through the code, unfortunately, because we just don't have time. You can check it out in GitHub. This code is, in my opinion, fairly clean and easier to follow. And so I would, if you're new to React, I would recommend taking a look at it. I'm going to show off the separate client and server version real fast now. So close all these things. So this is the project generated with the new React profile, the separate client and server. We have a client application, which is a standard create React app application. It does have a build.gradle file. We are using the Gradle node plugin, so we can still, if you are the Grails developer on the team, you can still run everything on the client side. You can run all the npm scripts by way of Gradle. And it also allows us to pull this into the multi-project build. The other advantage of using the Gradle node plugin is that it also lets you specify the version of node that you're using and set up some top-level conventions so that everybody's using the same versions of the tool. The server application is a plain Grails app. It's using the REST API, so there's no asset pipeline, no GSPs. It's just exposing everything over REST. And I'm going to go ahead and try to run this using the Gradle parallel option. So this allows us to run both client and server together. I'm going to zoom in here so you can see what I'm doing. So if you're not familiar with Gradle, Gradle projects can include a wrapper, which means that you can run Gradle tasks and Grails commands without having to have Gradle itself installed. So I can run Gradle boot run. And this is going to start up both the server project and the client project simultaneously. I found the server tends to start up first. Yeah, the Grails server is already up and running. So the npm, there we go. Okay. So before that loads, let's go ahead and load the server. So this is the Grails, there it is, okay. So this is what the Grails REST API gives you by default. It's just a bunch of application metadata. If you've seen the default Grails startup page when you create a brand new app, it's the same information, but it's exposed as JSON. And if you jump over here to the React app, this should look, if you're familiar with Grails 3, this is basically what it looks like when you create a new application. But this is not Grails. This is all React. This has been re-implemented using React Bootstrap. And all the metadata is the same metadata that we just saw in the JSON body. So this React app is making a call to the Grails server. It's already got cores configured, and it's retrieving this metadata. You can see our plugins. You can see how many controllers and services we have, and so forth. Okay. I think that's all I'm going to talk about there. So hopefully, I know this was going a little over time now, so jump ahead on our slides to the end here. Okay. So hopefully that gave you a kind of overview of basically the three main ways that I know of using React within a Grails application, which the third option is basically not with a Grails application, but there is some help to making the two projects play together. So we have the asset pipeline option. We have the combined project with using Webpack and Babel within a Grails application, and then we have just splitting them apart entirely and letting the two applications stand alone and just communicate over REST in their own projects. There was a last section which I'm totally skipping, but check out if you're interested in this. I do have some sample code and some slides on rendering the React code, the exact same book app we just saw earlier, where you can enter in a book and save it and whatever. Rendering that actually on the server through Java 8's Nashorn rendering engine. It's really interesting because it saves us. There's a bunch of reasons why people like to use server-side JavaScript. I'm not saying you should or shouldn't, but there's benefits for SEO and so forth. But the thing I found cool about it was that I was able to preload the data in my application without making any REST calls because I loaded on the server. So you can check that out on GitHub if you're interested in that. So a bunch of links. I'm not going to read them all off to you. They're all in the slides. It's all on GitHub. A bunch of profiles and stuff to read, and thanks.
Back with the three
Yes.
assumptions that you went over, do you have watch and live reload with all three versions?
Watch and live reload. I've gotten it to work with